All right, welcome to The Explainer. Today, we are going to pull back the curtain on one of the most popular and influential programming languages on the planet, Java. We're going to break down exactly how it went from just an idea to the digital engine that powers so much of our world.
So let's jump right in with the powerful promise that made Java a global sensation. Write once, run anywhere. Now, this wasn't just some catchy marketing slogan. It was a total game changer, an idea that would completely shake up how software gets made.
So, how'd they pull that off? Well, instead of writing code that only works on one kind of computer, like a Mac or a PC, Java does something clever. It compiles its code into this intermediate thing called bytecode. And that bytecode can be understood by something called a Java Virtual Machine, or JVM. You can just think of the JVM as a universal translator that you install on any device. Once it's there, that same piece of Java code works perfectly everywhere.
Okay, so to really get just how big of a deal this was, we've got to go back to the beginning. Let's take a look at how this whole revolution started.
Picture this. It's 1995. A team at Sun Microsystems, led by a guy named James Gosling, set out to create a new programming language. The idea was to make something high-level and, object-oriented. But the real goal, the big dream, was to finally achieve that platform independence we were just talking about. They wanted to smash the barrier that forced developers to write and rewrite their code for every single different machine.
Now, to really wrap our heads around how Java actually gets things done, it helps to think of it less as just a language and more like an entire architectural system for building software.
At the absolute heart of Java is this really simple but incredibly powerful metaphor. You've got the class, which is like an architect's blueprint. It defines all the potential, the properties, the behaviors, what something can be. And then you have the object, and that's the actual building, the real thing you construct from that blueprint. From one single class, you can create tons and tons of unique objects.
And here's what that actually looks like in practice. This little piece of code, public class student, that's our blueprint. It lays out the rules for what any student in our software is going to look like. From this single blueprint, we could literally create thousands of unique student objects, and each one would hold its own specific data, but they would all follow that same core design.
Okay, so every architect needs their materials and their tools, right? Well, Java's no different. Let's dig into the fundamental building blocks of the language. In Java, your materials are what we call data types. You've got your primitive types, which are like the raw materials, the wood, the steel. These are basic things like an int for a number, or a boolean for a simple true or false. Then you have reference types. Think of these as your prefabricated components, more complex things like a string of text or an array to hold a list.
So, you've got your materials. Now what? You need tools to actually put them together. And in Java, we call these tools operators. They're just special symbols that let you perform actions on your data, adding, comparing, combining, basically all the stuff that makes your program actually do something.
First up, you've got your arithmetic operators. You'll definitely recognize these from math class. Plus, minus, multiply, divide. One that's really useful is that percent sign. That's the modulus operator. And all it does is give you the remainder of a division. So, 10% 3 gives you 1, because 3 goes into 10 3 times with 1 left over. Super handy.
Next are the relational operators. These are your comparison tools. Is this thing equal to that thing? Is it not equal? Is it greater than? The key thing here is that they don't give you a number back, they just give you a simple, clean, true or false. And that is absolutely essential for making decisions inside your code.
And rounding out our toolbox, we have logical operators. These let you combine those true/false conditions we just talked about. So with the AND operator, you can check something like, is the user logged in and are they an admin? Both have to be true. With the OR operator, you could check, did the customer pay with a credit card or with a gift card? See? They let you build some pretty complex decision-making.
Okay, you can see how this all starts to build up, right? As your projects get bigger, you could have hundreds, even thousands of these blueprints in all their parts. So how on earth do you keep all of that from turning into a total chaotic mess? Well, the answer is all about organization,
and Java's got a brilliant solution for it: packages. You can just think of a package as a folder for your code. That's it. It lets you group related classes together, which keeps your projects tidy and, crucially, prevents you from having name conflicts. So you could have a student class in your admissions package and a totally different student class over in your library package, and Java knows exactly which is which. No confusion.
Okay, so packages organize your classes. But what about organizing your actual data? You know, like a list of every student's name or all the test scores for a class. For that, we use another key structure, the array. An array is basically just a container that holds a collection of items, but, and this is key, they all have to be the same type, all neatly stored together.
And making one is a really straightforward three-step process. First, you declare it. You tell Java, hey, I'm going to make an array. Second, you allocate memory. You set aside exactly how many slots you're going to need. And third, you initialize it. You fill those slots with your data. Declare, allocate, initialize.
So look at how far we've come. We've gone from the run-anywhere revolution to the blueprint idea of classes and objects. We've looked at the materials and tools, and even how to keep it all organized. And all of that foundation, that's what makes Java this incredibly versatile powerhouse that builds everything from the Android apps in your pocket to the huge, complex systems that run our banks and stores. So the real question isn't just about what has been built with Java, it's what could you build with it.